Hi, folks, and welcome to Chapter 13, Mineral Resources and Mining. So, look at your cell phone that's probably close by. Did you know that huge amounts of minerals are used in your cell phone, many of them incredibly rare? So that's why they encourage us to recycle our cell phones, and you should, if you have old cell phones, recycle them. Plus, on top of that, you might get a little cash from recycling them, because one of the minerals in there that you can see right here, all right, one of those minerals is actually very, very rare, and when we run out of it, we run out of it. So recycle those cell phones, folks. All right, so let's get into minerals. There's over 4,000 minerals identified, and only 1% of them are common. So most minerals are actually pretty rare, which is what makes them valuable to us. It's their rarity. All right, so what exactly is a mineral? A naturally occurring inorganic, which means it's made out of non-living substances, solid that has a particular chemical composition and physical properties. And so that's part of how we define which mineral it is by these physical properties. All right. The atoms of minerals are arranged in regular repeating geometric patterns, which is why you often see them with cleavage spots, that you can cut them quite easily, and that they have those crystalline type shapes that can occur. So most minerals are compounds. This particular one is pyrite, which is fool's gold, so it's not real gold. So if we look at our mineral use in our lifetime, we use a lot of minerals. So in the lifetime of an average U.S. citizen, this is in thousands of pounds of minerals that we use. So a lot of iron, because you use them in vehicles and in homes and things like that. But clays, phosphates, salt, other minerals, all of them we use quite a bit of. So when we look at the properties of minerals, and hopefully some of this sounds familiar from back in the day when you took earth science, one of the properties is the color of the mineral, and the color is going to vary depending on how the mineral is formed, okay? But different minerals typically have different colors, and you will have to use more than one property besides color to identify your mineral. Streak is the color of its powder, which can also sometimes be different than the color of the mineral itself. So if you remember in earth science that you would rub your minerals across a ceramic plate to see what their streak is. Luster is how light is reflected. So are they really shiny? Are they very matte looking? Are they metallic? What do they look like? Crystal is if they can be basically identified by the shape of the crystals that are within the mineral. Hardness is another thing, like you scratch a glass plate and see how likely it is to scratch it. So the softest mineral is talc, which can be found in talcum powder, which you can scratch very easily with your fingernail. And the hardest, of course, is diamond, and typically diamond is used to cut other minerals. Cleavage is also how the mineral breaks, so how it breaks has to do with its crystalline structure. So if it does break in a certain way, that can help you to identify them. There's also fractures that occur. This is when they break more irregularly. So there's no flat surface, no real cleavage going on at all. And then, of course, density. You can look at mass over volume to identify your minerals. How do these minerals form? Well, lots of ways. A lot of them form from magma or lava as it cools down. And usually the slower it cools, the larger the crystals you get. It can be associated with precipitation when water falls down and it carries minerals with it, like calcium deposits around here because we have a lot of calcium in our water. And that can build up over time. It also can have water evaporate, which can also leave behind minerals. Pressure and temperature, of course, can affect the formation of rocks. And then even the death of organisms when they leave behind like calcium deposits, either in their exoskeletons or in part of their body structure, and that can compress over time and create rocks. So coral is a good example of that. When you see coral pulled out of the ocean, it's typically just the calcium chloride that's left behind by the living organisms that are no longer alive there. All right, there are entire things like the White Cliffs of Dover, which are made from the exoskeletons of protists, for example. So all these things can be made in a variety of ways. There's lots of classes of minerals, and I don't expect you to have this part memorized, but basically look at minerals that are based on their elements and what they're made out of. So quartz, which is a very common mineral that you can find places, has a lot of silicates in it, okay? Whereas if you look down at the bottom at halite has a lot of salts in them, halides, and that's why if you lick it, it tastes salty, all right? So ore is what we're really concerned with because we're going to be going into mining. And when you're mining, that's what you're looking for. You're looking for the ore. And what an ore is a naturally occurring solid material found in our earth, which is a metal or other valuable mineral that we can remove from the earth and make a profit off it, okay, that we can make some money. In order to make money, what's inside this ore has to be a high concentration of a particular metal or mineral that is valuable, like this copper ore right now. Copper has really high, is very valuable right now. And so if you find copper ore, that's really good, and you can extract the copper from there and make some money. So how is this ore made? It really depends on the environment that they're from, but one of the ways they're made is hydrothermal, and hydro has to do with water, right? Thermal, like thermometers, has to do with heat. So as hot surface waters that contain dissolved minerals naturally, when they flow through the cracks in the rock, they actually dissolve the minerals that the rock is made out of, and then that can create new spaces and new places for other minerals to crystallize out of the solution in those cracks. And so then you get these little veins of a mineral. So gold does this very readily. You have veins of gold within the rock. And then we got the evaporites. This is when the water evaporates. I mentioned that in the last slide. And when the water evaporates, it leaves behind its minerals. And so you can get deposits of salt, for example, this way. And of course, when you're in a dry, arid place, you're going to have a higher rate of evaporation. And then you get a high production of things like salt and gypsum. So ore minerals are minerals that are valuable and economical to extract, just like we said before. It has to make sense money-wise. So one of the ores that we look for are metallic minerals. Metals are used a lot, obviously, and they conduct electricity. They have shiny surfaces. Some are opaque. They're really valuable. We use them for building. We use them in electronics. We use them for vanity things like with gold. So they have a lot of use and people will pay a lot of money for them. We also have non-metallic minerals that can also be very valuable. So these guys can be used as insulators, like clay. They use a lot of clay in creating your computer bits that make your computer run. They can be, gypsum can be used for a variety of things. So all these non-metallic minerals, they can be worth money too and also are considered ore. So all these things come out of rocks. So a rock is made of the minerals and mineral-like materials. And we have three main categories of rocks that should be familiar to you as well from earth science: igneous, sedimentary, and metamorphic. So the rock cycle slowly changes rocks from one type to another through a variety of methods, and basically any kind of rock can be turned into another kind of rock under the right conditions. So here's a picture of our rock cycle, and you can see the arrows go in every different direction. And you guys will be doing a web quest on the rock cycle where you will learn all about that, so I'm not going to spend a lot of time talking about that here. So here's our different kinds. Igneous, think of ignites. So these are hot rocks, okay? They form when a magma from a volcano cools, or from the core of the earth, and solidifies. And so there can be two kinds, intrusive or extrusive. And depending on which kind it is, it has different properties. Sedimentary forms over time very slowly when sediments sediment together or when water evaporates and leaves behind those minerals. So you can have clastic, chemical, or biochemical sedimentary rocks. Metamorphic, think of that means you're going to change, like metamorphosis. You're going to change because of heat and pressure. It's going to change the crystalline structure of the existing rock and turn it into a different kind of rock. So let's talk about mining a little bit. This is a separate note sheet if you don't know, and so you might want to pause here and open up your other note sheet, or just pause and come back to this later. So there's more than a ton of waste that remains after extracting just a few hundredths of an ounce of gold. So it's really hard to get a large amounts of gold out of rock. They do have good systems for separating gold out, but it takes crushing the rock and then separating the little veins of gold out and concentrating it. And then you have all this rock left over that all came from somewhere too. So while mining is a requirement for us to get the metals that we need to live the lifestyle we live, it's also very damaging to the environment. So as far as environmental science goes, it's how can we get these minerals that we use and impact the ecosystem the least that we can, all right? And then we're going to be talking about those different kinds of mining. So what is mine? Ores are mined, hence why we talked about ores in 13.1. So we mine them for metals or non-metals that can be removed. Non-metallic minerals that are very valuable include just regular minerals and gemstones, and all of these are worth it economically to pull out of the ground. And we can also mine for fuels to generate energy. So fracking is a kind of mining that removes natural gas from little pockets in the rock, and we'll be talking about fracking more later. So the process of mining and mineral use, this varies some depending on which kind of mining is occurring, but there's many steps to each kind. So one of the most common types of mining right now is strip mining. And so this is the picture I have put down here for you. When strip mining occurs, the first thing that has to happen is you have to remove all the vegetation from the mining site. And these are huge areas. So you can imagine there is a very large ecological impact by removing all the vegetation in that area. Then they remove all the topsoil, all right, and relocate that temporarily. Then they have to start blasting the rock to get down to the veins. So this particular picture is coal mining, and you can see the little veins of coal down there that they're trying to get to. So they will drill little holes down into the rock, and then they put explosives down in those, and they just blow the side of the hole open, essentially. So when that happens, it exposes some of the coal, so you can gather up the coal with an excavator, and that's going to be your main product. But then you have all this other stuff left over as well. So that's called overburden, and the overburden will be collected, and it will either be dumped into sites that they've already mined in and they're going to refill, or they will dump them in an alternative site to hold temporarily. In the United States, when they are done mining, they are required to fill in the hole in most places. So they will shape the overburden appropriately so that they can then use it later to reclaim that land. And then once they're done, they bring the topsoil back and then they replant trees. So it's great that we have this reclamation of the land now that this has been approved and it's enforced in most cases. But when they replant the forest, they're doing a monoculture. Everything is the same. And we talked previously in our forestry unit about how bad monocultures are for our ecosystems, and that all these trees are going to be even aged. And so there still is this very large ecological impact to the process of mining, but certainly reclaiming land is better than not. So mining methods. Strip mining, like I said, is one of the most common. That's when you remove the surface soil. Then you have subsurface mining. This is what you think about the old school mining that you hear about in the news because a tunnel collapses and miners get stuck in the tunnel. So these are underground. They're very dangerous, which is why they're not as common anymore, but of course we do still use them. Open pit mining is also very common. This is digging a large hole that usually turns into a quarry. And then you got mountaintop removal, which unfortunately is gaining popularity, and this is actually the most destructive form of mining, where the mountain is basically just blasted away. And unfortunately, this is what they use a lot of times to get to coal. All right. We also have things called solution mining. This is what fracking is, where you use liquids to blast the rocks open and then collect the gas. Placer mining is the least destructive, and this is the old school type of mining where you go into a river and you take a pan and you run the water through the pan trying to find minerals in riverbeds. And then undersea mining, which is becoming more common as well, is dredging the ocean floor, and this is catastrophic to that ecosystem. It's really a terrible thing, and unfortunately it is occurring to oil when you are mining for fossil fuels like oil. So once you get the ore, you have to process the ore in order to basically purify the metals as much as possible. So they take that ore, because remember it's rock mixed with minerals, and they crush it. By crushing it, they can then separate the ore from what's called the tailings. These are the waste that's left over. And sometimes, like in the case of gold mining, they separate it out by density. So they use water, and the water will push all the gold to one side, and the rock, which is heavier, will go to the other side. So this makes concentrated metals that you can then further process by smelting them, which is when you melt them, and that's what they do here. This is a picture of an iron working factory, smelting factory, sorry, where they basically liquefy it and then they pour it into these long blocks that they can then transport to be made into other products.